A circular rigid loop of radius r and mass m lies in the xy plane or flat on the table, current flowing in it, blah blah blah. At this particular place, the Earth's magnetic field is this. How large must be I before one of the edge will start lifting from the table? Tell me, what is the doubt here?
I wasn't able to solve it.
Bx by, let's say the net magnetic field in the plane is in this direction, root over bx square plus by square. Is that okay?
Yes, sir.
Now this direction I'm calling it as nu x dash. So let's say this is x dash. So net magnetic field is in this direction. What is the direction of force on this half?
So downwards.
Downward. And this one?
Upwards.
So this is pulled upward, this is pushed downward. So this wants to lift up, this wants to go down. This can't go down, but this can be lifted. If lifting will happen, then lifting will happen. Lifting will happen about which line?
5. Sir.
5, correct. So if it is just about to get lifted, then the torque of magnetic field and the torque of gravity will balance because the normal will shift at the corner. So about this lifting axis, when it is about to lift, because this point will be pressing hard downward like anything, so it will be in contact, and this point being in contact will not move. It can't go down, and anything not able to move in the rigid body lies on its axis of rotation. So axis of rotation will be like this. So with respect to this, anyway, the normal is here only. Normal has shifted to the corner. So let's talk about the torque. So m vector will be like this. B is like this. So m cross B will be clockwise. It wants to lift like this. But mg will have an anti-clockwise torque. Can you tell me how much will be the torque of mg?
Mg into R. Sir.
Clockwise or anti-clockwise?
Sir, anti-clockwise.
And what is the torque of the current? I mean torque of the force from magnetic field?
So 2 pi R into I into B into R. Sir.
2 pi r into
I into B into R. Sir.
how you got 2 pi r into I into B into R?
Sir, like since force on the loop is 0, sir, about any axis the torque will be same, sir.
Okay.
So I calculated torque about an axis passing to the center, sir.
Okay, what is the torque formula you used?
So I took some d theta elements, sir.
Okay, anyway, let me see. Torque is equal to m cross B, na?
Yes, sir.
Why are you getting 2 here? Tell me what you did in integration.
So I took r d theta elements.
Theta you took?
Yes, sir. At some theta there's some r d theta elements, sir.
Okay.
So force on this r d theta I calculated, sir.
What is the direction of force?
Sir, So downwards.
Downward. So force is, what is the angle between DL and B?
So 90 plus theta, sir.
90 plus theta. So sine of 90 plus theta is cos theta. Then
So this is the force, sir. So to get torque, I have to multiply by r cos theta, sir.
theta integrated from
So 0 to 2 pi.
what will you be getting as the integration?
So pi into I b r squared.
You got 2 also now. How you got 2?
The 2 in the denominator I missed.
Okay, no problem. So this torque I pi r square b I equal to mg by pi rb. Now what is the value of b that will be put here?
So the b net values, sir.
Is that clear?
Yes, sir.
Mg by pi r, yeah, same thing we are getting. The total magnetic field in the plane matters. Perpendicular to the plane doesn't matter. Yeah. In some of the option, there is a perpendicular component also, so we'll leave this. It's a stupid thing.
Yes, sir.